Hello class, today let us learn what is cofactor of a tensor. So if A is a second order tensor, okay, with the components Aij, then the cofactor of a tensor denoted by A star, and some books also denote it as A arrow then star, and its components are given by A star ij are given by half 2 epsilons, 2 permutation symbols, right? So ij here, so 1 I for 1 epsilon and j for another epsilon. Then we have p, q. Then we can choose another 2 suffixes r, s. So a, p, r, a, q, s. This is the cofactor of a tensor of second order, right? Now we can define what is adjoint. Adjoint of A is nothing but take A star, okay, then interchange rows and columns. So here we have to interchange rows and columns. So A star, take A star. So Ji. If Ij is cofactor, then adjoint of A is interchange the rows and columns. That is the transpose of the cofactor tensor. Okay. Now we shall go to the identity. We shall prove one identity using this cofactor of a tensor. Let us take the identity. Identity is this. So we are going to prove that A star A cross B is equal to A small a cross A small b, where small letters A and B are vectors and capital A is a tensor. See, I've used both the notations. Here I've used tilde notation and here I've used arrow notation. You can use any one. So now take LHS. So what is our LHS? LHS is A star A cross B. Small a is a vector, small b is another vector, A cross B is a vector. Then this A, capital A, is a tensor of order 2 and this product is a vector. So one free suffix, so we'll take I there. Okay, that is equal to, the product definition is this. So A star ij A cross B, and for this it is J. This is the definition of the product of a second order tensor and a vector. Okay, yes. Next step, that is equal to, we'll use what is A star definition. So A star definition I'm using now. So it is half 2 epsilons. So 1 epsilon I P Q, another epsilon it is J S, okay, A P R, and then A Q S. So this part is nothing but A star of Ij. Right. Now next I want the remaining. The remaining is this. So for that I'm getting one more epsilon. What is cross product? How do you write cross product in terms of tensors? So I want the jth components. So epsilon j and any other two dummy suffixes. So I will take mn. For the first vector a, it is m. For the second vector b, it is n. Okay. Now in the next step, we'll write all the epsilons together. We'll write all the epsilons together. So that is equal to epsilon half. We'll write all the three epsilons together. IPQ, epsilon JRS, epsilon JMN, APQ, AQS, AM, and BN. We have written all of them together. Now look at the epsilons and also look at their suffixes. Okay, so what are the suffixes? Is there any common suffix so that we can use epsilon delta identity? That we'll check. So just check all the suffixes. We have I, P, Q, J, R, S, J, M, N. We can easily see that J is dummy here. J is coming for two epsilons I'm getting J here. So we can use epsilon delta identity for these. Okay, we'll see now. Now to use epsilon delta identity, I want this J to be in the third place. Right? In the third place. Here I want this J to be here. So what do I do is I'll just shift that here. We'll see that in that. So half, only that is a change in the next step. So epsilon IPQ as it is, no change. Now here what I'm going to do is I'm going to change it. In what way I want, I'll just write that. Okay, it is nothing but I'm going to see, I'm taking RS J. This epsilon, no change in that, it is JMN. Okay, so when I'm changing this, is there, is the order changing? That we'll see. Now, JRS, let us take the triangle. Okay, this is J, this is R, and this is S. So, JRS is cyclic or clockwise. Okay, now what about RSJ? RSJ, that is also cyclic. Both are in the same directions, no? So, no sign change. So, this is equal to this. This is equal to epsilon JRS. Fine. So, no sign change. The remaining as it is. Everything is same now. PQ and A, QS. So, it's R no here. Here. Correct, no? See. This is R here. And QS. QS, AM, BN as it is. Okay, now this I don't want now. So, I'll just write it up. Now we can use what? The epsilon delta identity for these two epsilons. That is equal to half. Okay, so epsilon IPQ as it is. Now for these two, we are going to use delta notations. One bracket here. So epsilon delta identity I'm using now. So delta minus delta. 4 deltas, no. The remaining as it is, that we'll write later. Now, look at the remaining. Now, J, I cannot write now. The RM, first delta, it is R. First letters, okay. First suffixes I'm writing. The second suffix, for second delta, it is yes. Yes. Here also it is the same thing. R and S. Let this bracket little away. Yeah. So here also it is yes only. Now for the second place, now look at M. For first one it is M. Then N here. Now here it is here for the next two epsilons, they just interchange. It is N and N. That is our epsilon delta identity. The remaining as it is. So APR, AQS, AM, BN as it is. That's equal to half Now you have to multiply everything together. So IPQ, just multiply now. So delta RM, delta SN, APR, AQS, AM, BN as it is. Then there is minus sign. Half I'm taking common, so I'm putting my bracket there. The remaining minus I have written already. So epsilon IPQ as it is. Same terms. So delta Rn, delta Sn. That is only change. The remaining as it is. M, then Bn. Is it not easy? Next. So now we have to apply delta now. So we'll apply delta. So half, okay, epsilon IPQ as it is. Now this delta Rm will act on AM. Okay. So let me write APR as it is. AQS also as it is. Right. Now these two, this delta will act on AM, no? So in the place of M, R will come. Then this delta Sn will act on Bn. So when it acts on Bn, so in the place of N, S will come. So minus as it is. So IPQ. Now I think you can easily guess now. So let me write this part, APR and AQS. Let me write it off. Now this delta Rn acts on Bn. So it will become B in the place of N, R will come. Similarly, this delta Sm will act on Am, right? So A in the place of M, S will come. Okay, so that is okay. Now we'll combine the terms. Which two will combine? This and AR will combine because I can see a common dummy suffix over there, R. Similarly, I can combine QS and BS, right? Okay, so let me write that off. So IPQ as it is. So I'm combining, I'll put a bracket and combine, okay? So I'm putting, APR, okay, AR. We combine these two, then AQS and BS will combine. Minus epsilon IPQ. Similarly, can you guess now? It is APR and BR. I can combine. So it is APR, BR. Then we have AQS, US. Right. So now we have, we'll combine, no. So we'll write in terms of, tensors. So that is half as it is. Change over there. So we have epsilon IPQ. Keep that as it is. We have this, the first bracket. We'll write that as A. Okay. And we have small a here. There is small a here. So small a. Okay. And R, R. So R is dummy there. So P is the only free suffix. So P will come. Similarly, this part will be A because these are the coordinates of A. And we have BS, no? So small b and SS is dummy. So Q will come. Right? Minus epsilon IPQ. Can easily guess now. Tell me now. So it is A, B. Okay. And which suffix will come there? P is the suffix over there. Now for the remaining, it is A, small a, the same lines. Right. So now we have that is equal to our half is as it is outside. Now just watch the first full term, big term. You have epsilon IPQ. You have one, vector with the components P, another vector with the components Q. Now this is it not cross product of those two vectors? So it is A, small a, cross. Second vector, it is capital A, B, one bracket for that. And which component? P is dummy, Q is dummy. So you have I here. So I component of that. Okay. Minus the remaining now. Minus, look at again epsilon IPQ. Same, similarities. So what is the first vector over there? It is A, B, cross A, and which component? There is the suffix is I here. So I is the free suffix. So I component of this. So we get half, right? Just writing it again. Very simple. Okay, minus second part as it is. Okay, for the full it is I. And now that is equal to half. First vector will keep as it is. Now can you guess the next step, guys? Okay, now second one, interchange, first let me write this. Okay, so what is happening to the sign now? It is becoming less there. Correct? No, we know A cross B. B cross A is nothing but minus A cross B, right? Okay, now that is equal to, for the whole thing, of course, I as it is. So we have half. Now see this and this same, no? So it is twice. A cross A, B, of course, I outside. 2 will get cancelled. So we get vector. Yes. Components are same. So therefore, this is nothing but our RHS. Hence, the identity. Very simple identity. So let's stop now. And the next class will prove one more identity.